Hello, my name is Arnav, and today I'm here with Sachi, Christian, and Jason, and we are RAMbotics competing in the NeuroMaker Creative Engineering Challenge.
Design statement. Our goal for this challenge was to enhance the functionality of the existing prosthetic hand by incorporating wrist mobility to expand its range of motion. Wrist mobility enables a multitude of dynamic gestures, allowing for us to engage in activities such as waving, writing, playing sports, typing, and so much more.
There are 6 main types of synovial joints, each with its own unique structure and range of motion. The wrist joint, also referred to as the radiocarpal joint, is a condyloid synovial joint. A condyloid joint is a modified ball and socket joint that allows for flexion, extension, abduction, and adduction movements.
So our first step along the process of expanding the flexibility of the hand, which was not included in the original design, was to generate concepts, to brainstorm. So we started off by measuring the hand, and then we figured that the best way to include flexibility in the hand was to include a ball and socket joint to represent the wrist. So we 3D printed a ball and socket joint and added a new platform for the string separator. That is for the servo strings to go through and to connect to the new joint. And we placed the ball and socket where the wrist should be, and that is where the joint currently is. And we added 4 servos with new strings onto the support and connected the string to the outer hand. And then we programmed code to allow for gestures like waving or a handshake. The next step was to come up with some schematics for the new 3D components, and we used Tinkercad to model out the ball and socket joint and the string separator, as you can see in these attached images. And so here we have our 3D printed string separator, which goes on top of our new design of the hand. And we have the ball and socket joint inserted behind the servos, which is typically where we're at, as you can see this way. And so the string separator goes on top of the ball and socket joint on the platform where we designed it. And it fits on like so. And so the casing would be attached on the back, and the hand would be attached on the top of the string separator, and the strings would fall in between these holes. And with this added new ball and socket joint, we have nearly 360-degree movement around the wrist. As you can see, this goes left and right, back and forth, and any other direction you wish.
Our design is clearly at its early stages and not completed, considering we did not have the time to add servos to get the joint to move on its own. We hope that in the future we can incorporate servo motors to bring life to our joint mechanism. We look forward to exploring these possibilities and continuing to refine and improve our project. Some of our future ideas include simulating touch and sensation using thermoreceptors and mechanoreceptors, increasing grip strength and adding a skin. This means it's less slippery and the fingerprints more realistic. Adding opposable thumbs, making the hand wearable, and lastly, adding electrical conductivity, and this means being able to use a smartphone connected to the hand.
And these are our citations. Thank you, NeuroMaker Creative Engineering team, for your time and consideration.